Hello to my students. If you missed, let's see, what day was that? Monday? Why am I thinking Monday? Hold on one second. All right, let me let me correct that. Okay, Monday and Tuesday we took part 1 and 2 of the test, and then on Wednesday we started our new unit, Unit 6. So if you missed Wednesday, the 15th, right? 13th, 14th, 15th. Yes, if you missed the 15th, this is a good video to watch. So what we did was I presented um, exponential functions with Pay It Forward. Maybe some of you guys have seen this movie. I played a quick clip in class of this boy explaining that this teacher gave students an assignment to change the world, and this was his way of changing the world. He was going to start with just him. He was going to help 3 people, something really big. Um, and then each of those people that he helped, if they helped 3 people each, then it would expand exponentially and there would be so many people helping other people. So we looked at, okay, well, at the beginning there were zero cycles, we called them, and there was 1 person involved. And then after 1 cycle, there were 3 people involved. And then after 2 cycles, there were 9 people involved. And we looked at, okay, well, what's happening to these numbers? Well, each time we're increasing um, the degree, I guess, in a sense, of my power of 3. So we have times 3 times 3 times 3, and each time we're multiplying again by 3. So here we looked, we could rewrite 27 as 3 to the 3rd power, just like we could write 81 as 3 to the 4th power. So if we wanted an equation for this, well, when x is 4, our y is 3 to the 4th power. So we decided our equation would just be y equals 3 to the x power. And once we got up here, how did we get 1 as our y value? Well, 3 to the 0, anything to the 0 power gives us 1. So, all right. So we looked at that, and then we graphed it. Let's look at the next page. I think it's a couple pages. We graphed y equals 3 to the x. Now, I'm going to ask you to do some negative values and some positive values. So we start -2 to +2. We want to use these values, and we plug them in. We plug them into our x, and 3 to the -2 is the same as 1 over 3 to the +2, which is the same as 1/9. And then 3 to the -1 is 1/3. So we got 1/9, 1/3, 1, 3, 9. And you can probably see there's a bit of a pattern there. We have to be careful when we have a negative exponent. It's 1 over becomes the reciprocal. All right, so then we graph this. And notice this red line right here is called an asymptote. Let me write it in red. Asymptote. And our asymptote is at y equals 0. This is a line that the graph approaches as we move away from the origin. It gets really close, but it never actually gets to 0. So our fraction gets bigger and bigger, or smaller and smaller, really. So we get 1 over 27, we get 1 over 81, and then 1 over 243. So it gets a smaller and smaller number. If you look in your calculator at the table, it ends up going into scientific notation and it gets very small. Okay, so this is an example of exponential growth. Let's go back 2 slides. Okay, so we kind of went through each one of these and we talked about what each thing meant. So we got the exponential function, b is the base. It needs to be a positive number other than 1. So we looked at, well, what if it's not a positive number? What happens if it's a negative number to an exponent? Well, what's that graph going to look like? And we decided, oh, well, to an even power, it's going to be positive, and to an odd power, it's going to be negative. So it ends up doing this oscillating pattern that you can see. It's kind of cool, actually, but that would not be an exponential function, nor would this if our base was 1. 1 to the x. 1 to any power is going to be 1. 1 times 1 times 1 times 1 times 1, still going to be 1. So this is just a linear function, actually, and you just get a line. So we restrict our base from being 1. And then a growth occurs when b is greater than 1. So we went over here and said, okay, what about 3? Is 3 to the power of x? Is that a growth? Yes. 3 halves to the x. Wait a second, that's a fraction. Is that okay? Well, we need to check. Is b greater than 1? 3 halves is 1.5. So yes, that is still a growth, even though it's a fraction. It is not a fraction between 0 and 1. It's greater than 1. So this is a growth. Whereas something like this would not be. That would be a decay function, and we'll talk about that in a couple videos. All right. So an asymptote is a line that a graph approaches as you move away from the origin. And I do want you guys to graph the asymptote as a dashed line. If you graphed it as a solid line, it would say, well, this is part of the graph. And it's not really, it is, but it isn't. You need it kind of as like a guardrail, but it's not something that when you plug in it, it's not the input-output value. So we're going to put it just as a dashed line. Then also we looked at, well, what if a was negative? Here, let me pull this up. If a was negative, because here we have, well, an exponential growth function is where a is greater than 0, which meaning a is positive. Well, what if a was equal to 0, and what if a was less than 0? If a was negative, then we would have a reflection of our growth, right? So here's our growth function. We would have a reflection of our growth, which doesn't look like it's growing very much, does it? This is just a reflection of our growth. So here we have a's as restricted. And then b's, oh, I'm sorry, if a is equal to 0, you have y equals 0 times anything, right? What's 0 times anything? You're just going to get 0. So that would be a line. So we need to restrict these cases because they wouldn't be a growth. All right. So b is greater than 1. That would give us a growth. All right, then we looked at this, and this is something that I am going to expect you to do. Part of it is you're showing me that you are doing the work. You're allowed to use your calculators to check your work, but you need to show me each different transformation that's happening to your parent function. So we're going to put our parent function values in here. Parent function values go here. Now I'm asking you to start from -2 to 2, and depending on our base, these y values are going to be different. We might have 2 to the x, 3 to the x, 4 to the x, 1/2 to the x. The base is going to change. So we need to take our -2, plug it in. Okay, but this is the stuff that's not going to change. We are always going to multiply our a value, our stretch or compress, to our y values because a stretch affects the y-axis. And then after we do that multiply, we need to multiply first. After that multiplication happens, we can add k. Now it might be minus k if k is negative, then we would subtract k. But we just do whatever k is telling us to do. K also tells me where my asymptote is. My asymptote is at y equals k. Now, if there is no k, then it's at y equals 0, so k is 0 if you don't see one. What else? And then be really careful, x minus h. So here we're doing x plus h, right? Because it's the opposite. All right. We already looked at that. And finding the y-intercept, right? So we looked at a couple things. We went y equals 5 to the x, y equals 2 to the x, y equals 3 to the x. And we graphed all three of those. I think maybe you may have graphed them on the calculator. And they look something like this. I'm just going to kind of do these really quickly. This is an approximation. Okay, so we've got, oh, no. Let's try this again. Undo. Okay, so we're going to have this be my axis. Okay, so this point right here is very important. I'll show you why. I have to fix that. It looks like it goes underneath. Okay, so we've got y equals 5 to the x. Again, I'm just quickly drawing these. I'm not using exact. I'm just doing this one point exactly. But this is increasing at a faster rate than y equals 2 to the x or y equals 3 to the x. But I wanted to note it. I want everyone to notice that they do share 1 point if the y-intercept. So to find the y-intercept, we're going to plug in 0 for x. All right, so if we plug in 0 for x, we get 5 to the 0. So make a quick t-chart, x, y, x, y, x, y. If I plug in 0 for x, 5 to the 0 is 1, 2 to the 0 is 1, 3 to the 0 is 1. All right, so this point 0, 1 is something that's shared by all three of these functions. They also share the asymptote. Asymptote for all of these functions is y equals 0. All right, so then we looked at, oops, too many pages. Okay, right here we have 3 times 2 to the x. So notice 2 to the x is staying the same, but the only thing that's changing is my a. And notice when I had 3 times 2 to the x, because if I plug in a 0, oh, I'm sorry, if I plug in a 0 for x, I get 2 to the 0 is 1, and 1 times 3 is 3. So my intercept, my y-intercept, just changed now to 1 times 3. So here my intercept went up to 3. Here my intercept changed to 1 times a third. So if I have a stretch or compress, my 0, 1, that intercept is going to change depending on my stretch or compress. So if it changed to negative 1/5, it's here, and negative 5 all the way down here. All right. Okay, so to find the y-intercept, you plug in 0 for x. And then we did one example. Let me close this so you can see a little better. So the asymptote is y equals 5, and I notice I can find that right here because it started at y equals 0, it shifted up 5. We've got our x and y start values. I started with -2, -1, 0, 1, 2. Plug those in just to the parent function. I ignored all of the transformations. I just used the parent function to find 3 to the -2, 1/9. 3 to the -1, 1/3. 3 to the 0, 1. 3 to the 1, 3. 3 squared, 9. I get those values. Then I decide, okay, I need to multiply my a, 2, times my y, because that's my stretch and it affects the y-axis. So I double each of those values. Then we shift up 5. So I'm going to add 5 to all of my 2y values. So add 5, add 5, add 5. Beautiful, those are my new y values that I'm going to use. That's why I circled them. And then the x's, we need to be careful. X minus 4, so I'm going to add 4. So I add 4 to all of my x values. And then these points are the points I plot. I graph them. I make sure that my graph does not go below the axis of, I'm sorry, the axis of symmetry, the asymptote. So the asymptote you want to draw as a dashed line and label y equals 5 is my asymptote. And then you're good to go. All right. And that was what you missed if you missed class.